Hello friends, welcome to our channel. Let's look at problem 2444. Count subarrays with fixed bounds. This is today's daily challenge problem, and this problem is marked hard by leetcode. Actually, if you know how to reduce the problem to be a plain type problem, so solving it should be not very challenging. So here the main point is the reduction of problem. So the method we're going to use to solve the transformed problem will be two-pointer sliding window, right? So actually after this video, it's good that you compare the solution here with the video for leetcode 2799. In both the coding or solutions I present, so I will use step back one step in the two-pointer sliding window method. This is actually some fun details. It basically demonstrates that you can control the procedure at your disposal. So you can find detailed walkthrough of examples in a previous video on this problem. So here is the link. So here I want to comment that in the previous video, the solution is very neat, but I like the strategy here. We first do reduction of problem, and then we use two-pointer sliding window method in a more modularized way. So here I'm not going to read through the problem statement, but there are 2 points I want to mention. First, what's a fixed bound subarray is defined here, right? So all the elements should be within this 2 numbers, and also this 2 number should appear. So the length is, the second point is that the length can be as long as 10 to the power 5 or 10 to the power 5. In other words, we need to think of time complexity. So with that said, let's look at the coding. So here we can first reduce the problem to counting with all the elements within the bounds, right? So this can be easily done. So in other words, our coding will be 2 parts. One part is do partitions. The second part is a two-pointer sliding window function. Two-pointer sliding window. And then finally, we do the return. So the first part, let's see, partitions. So I'm going to add a empty list first. So this is just for the ease of writing. You don't need to do it. So, but this way, it brings some convenience. So now let's linear scan this nums for y in nums. So if min k less than or equal to y less than or equal to max k, in other words, inbound, right? So if it's inbound, I'm going to do partitions, the last list. So we're going to append this y, right? Otherwise, out of bound. So if it's out of bound, and then if partition -1, so we cannot put things in this again. So what we do is partitions. So I'm going to append an empty list. So that will be it. So now you can print out this one. Print partitions. So let's see what you get. For this one, you should get 1, 3, 5, 2 because all those 4 numbers are inbound. But 7 separates this because this is outbound. So now you get 5, right? The second one. For this example, you will get a single one, right? So this will be the case. So now that this is right, so basically we want to solve next problem. That is the hint item 1. So if all the numbers in the array were between min and max, can you do the count? So this is nothing but the two-pointer sliding window method. I'm going to write it as a hyperfunction. So we have some array, and then we have 2 bounds, right? And then all the numbers, let's assume all the elements are within these 2 bounds. But how do we do the counting for fixed bound subarray? So this will be standard two-pointer sliding window method. So here, actually, there are some correctness proof. Basically, let me first write the code, and then if we have time, we will touch a little bit about that. So we get the result. So this is the counting variable. We are going to return its final state. So because later we are going to return this result. And then we have a window. So this window will have the number and the frequency, unique numbers and frequency. And what we actually because we just need to check two numbers, we don't need to introduce too many variables. Let's see, n will be the length of this array, right? And then we have a left top pointer will be 0. Then for the right pointer, so for I in range n, so we are going to iterate. So our goal is to find all the possible fixed bound subarrays ending at this index I. Then if we can find this, we just summation over index I, we get the final return. That's our purpose. So now let's look at this. So once we have this, what we do, window array I will be incremented window get. And because it's possible, this is the first time this array I appear. So we write like this. So now we want to do a check. If k in window and k, capital K, also in window, then I want to find the smallest left bound, right? Or the largest, the first L. Let's see, find first L such that from L to R, if you consider array, is not fixed, not valid. But array, so from L minus 1 to R is valid. So that's our strategy. So what we do is this. We do a check. If this was a condition, then we do a while loop, right? Well, K in window and this capital K also in window, because this window is a dictionary, so the membership check is O1 operation. So this is actually very fast. So what we do is that, so window array L will be decremented by 1. So the way we can write like this is because L is always in between this window, right? Therefore, array L will always appear in this dictionary. So then, if window array L equals 0, then we're going to delete this part, right? So this is the case. Then we're going to increment the L by 1, right? So now we at this stage. So basically, it tells that from L, once you have the current state of L, so this condition will break. In other words, from L minus 1 to R to I. So this is a valid one. Then it implies that array from 0 to I valid, and then from 1 to I valid. Then from, let's write this as I naught. So the I naught can be I naught less than or equal to L minus 1. How many possibilities? The end minus the beginning plus 1. L minus 1 minus 0 plus 1. That is L. So we're going to result increment by this L, right? So, but in the window, as I mentioned, I want to always include the left pointer. What do we do? So we do L minus 1. So, and then we do window array L. This time again, we're going to do this, get array L, and then 0 plus 1. So here, let's see, step back, one step. This is crucial. So you can also see this step in the video for problem C2799, right? So once you have this will be logically correct. So what you do actually is just return the result. So now let's see. We have this one. I have already read this. Let's just comment this out. Now let's look at the return. So we just need to apply this function to every component in this partition. So now let's do the return. So return summation hyperfunction. So the array or the item. So min key and max key for array in partitions, right? So this will be the full coding, and you can see it's very modularized. So we do partitions, and then we do 2-pointer sliding window, and then we get the return. Let me first run and then make some comments. Yeah, it passes the 2 test cases. So now let's look at the generic case. Yeah, it passes all the generic cases. So now let me do some print so that you know what's the some details. So let's see. Here, let me do this. For array in partitions, let's first print out the partition. Print partitions, and then what we do for array in partitions, print out array, and also print out let's see contribution. Let's see, will be hyperfunction, the array min key and the max key, right? Print f contribution. So now let's see. Let's see. Oh, this one just contribute 10, just one element, right? For this one, so this will contribute to us 2, right? So this contribute to us 0 because 1 does not appear inside this array. So I guess that's basically about it for this problem. So here, let me do a quick summary. So here, what I want to emphasize is that the reduction of the problem can be important. So once you do the reduction, you can identify the problem type, then solving it should be rather straightforward. So this is the one comment. Another comment is that in our YouTube channel, so we have a playlist on 2-pointer sliding window method. There actually it accumulates a large number of problems. You're welcome to check out those videos and do some practice. Hopefully it will be of use to you. With that said, I guess that's it for the current video. Thank you.